All right, what's up, everybody? Quick do now, some review from lesson 5.3. Okay, remember isosceles triangles, we see that they have congruency marks. They match. We can also see that 10 and 10. That means they are the same. So that means if we draw opposite arrows, that means those two angles are the same. And if that one is x and they are the same, that means this one also has to be x. So that means all angles of a triangle add up to 180. So x plus 72 equals 180. Combine like terms, x plus x gives you 2x plus 72 equals 180. Subtract 72 from both sides. Those cancel. We're left with 2x equals 180 minus 72 gives you 108. Divided by 2 on both sides. X is equal to 2 goes into 10 5 times, 2 goes into 8 4 times. So that means each x is 54. That angle is 54. That angle is 54. Okay, here x, this is our mid-segment. Remember we said mid-segments are half the length of the third length that it's parallel to. We see that these two are parallel to each other. So to find x, we just divide this by 2. 24 divided by 2, that means over here x must equal 12. That's it. There's some review. Okay, today that should say lesson 5.4, equilateral and triangle inequality theorems. Okay, so again, review, pretty similar to what we just did. With that do now, the mid-segment is always half the length, so 30 divided by 2, this mid-segment is going to equal 15. If we change the color over here, we see that we have isosceles triangle. That means that angle is congruent to that angle. Since we don't know what either of them are and they're the same, we can label both of them as x. So again, that means x plus 68 equals 180. X plus x gives you 2x plus 68 equals 180. Subtract 68 from both sides. 2x is equal to 180 minus 68, gotta borrow. 10 minus 8 gives you 2, 7 minus 6 is 1, 1 minus nothing is also 1. 2x equals 112, so we divide both sides by 2. X is equal to 2 goes into 11 5 times. Left over, 2 goes into 12, 6. So that means x is equal to 56. 56. This one over here is going to be 56 as well. So just some quick review. Okay, the equilateral triangle theorem. Similar to what we said with isosceles. Again, I apologize. Hold on. If you go into Canvas, right, the notes are available here for lesson 5.4. Notes are available and the slides are available for 5.4. Please use those while you're going through this video. The equilateral triangle theorem, if a triangle has 3 equal sides, then it also has 3 equal angles. And similar to what we did with the isosceles triangle theorem, right, the opposite angles are going to be equal to each other, right? If you see an opposite or an congruent side, if you draw an arrow across, that means that angle is also going to be congruent. But in this case, since it's equilateral on all 3 sides, then you end up drawing arrows to all 3 angles, so that in the end, it doesn't quite matter as much in equilateral as it did in isosceles. Okay, all equilateral triangles are equiangular. All equiangular triangles are also equilateral. So what are the measures of the angles in an equilateral triangle? All right, well, we just got done saying that if it's equilateral, it also has to be equiangular. And even if we don't know what any of these are, we know that they all have to be the same. And if they're all blank, remember, we just label it as x. And if it's all a bunch of x's, that means x plus x plus x has to equal 180. Well, if we combine like terms, x plus x gives you 3x equals 180. You divide by 3, and we get x is equal to 180 divided by 3 is 60. All right, so that means each of these 3 angles, they will always be 60 degrees. Triangle inequality theorem. This one's interesting. It's a little tricky, but it's very interesting when you see how it plays out in real life. Okay, the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So it doesn't matter which two sides you take, whichever side is left over has to be less than the other two sides added together. So if you take sides A and B, whatever they are, when you add them together, it has to be bigger than whatever C is. If you take C and B, if you add those two together, they have to be greater than whatever A is. Again, and same thing with AC. If you added AC together, it has to be bigger than whatever B is. No matter what, you cannot create a triangle if it does not fit this theorem. So it's just add the two smaller numbers and see if it's larger than the largest number, right? That's a quick way to just get to see if you if three side lengths can make a triangle. If you just do that, right, rather than having to do it for all of them. Okay, so side lengths 10, 4, and 3, right? In order to see if it creates a triangle, you have to add all two of them together and see if it's bigger than the third. So if we take 10 and 3, 13 is definitely bigger than 4. That works. 10 plus 4 is 14, which is obviously bigger than 3, as work, right? But again, if you add the two smaller numbers and see if it's larger than the largest numbers, that's going to be the quickest and easiest way to see if it creates a triangle. If we take 4 and 3, add them together, that's 7, which is obviously not bigger than 10. And the reason why we see, like, it literally cannot work if you have side lengths of 4, 10, and 3. You could never create a triangle because these side lengths are not big enough to actually touch each other and create a triangle. Okay, so some examples. Can these three lengths make up a triangle? Remember, the hint that we just got done saying is add the two smaller numbers and see if it's larger than the largest number. Okay, so we take here, this two smaller numbers is 3 and 4. So 3 plus 4 is 7. 7 is definitely bigger than 5, so it works. It totally can make a triangle. 8 and 8. Well, there isn't really a larger or smaller side. So if we just take 8 plus 8, we know that's 16, and 16 is definitely bigger than 8, which means, yes, it can create a triangle. 5, 4, and 10, we take the two smaller sides, 5 plus 4, which is 9, which is not bigger than 10. So 10 is bigger, which means no, it cannot make a triangle. It would be impossible to have a triangle with side lengths of 10, 5, and 4. 2, 2, and 5, again, take the smaller ones. 2 plus 2 is 4. 4 is smaller than 5, so again, no, it cannot make a triangle. If they cannot form a triangle, we must explain why, and the reason why is because the two side lengths are not bigger than the third side length. If we are given two sides, the third side can be a range of numbers, okay? Because obviously you don't know what it could be because it just has to be bigger than the other two added together, right? So that means that's why we say it can be a range of numbers. It has the ability to be more than one number. So if we have a triangle with side length 2, side length 5, and an unknown, that means that unknown would be can be a range of numbers. So step 1, set up two inequalities, one beginning with x, one beginning with the larger number, and solve for x. Okay, so remember, the third side length has to be smaller than the other two side lengths added together. So if we create one with x, right, that means x has to be smaller than adding together 2 plus 5. And then one beginning with the larger number. So the larger number is 5. That means 5 also has to be smaller than 2 plus x, because that's still our third unknown. All right, so if we added this together, this would create x has to be less than 7. And if we solved here, right, we would just solve this just like an equation. It's just a greater or less than sign. So we subtract 2 from both sides. 5 minus 2 is 3. That means x has to be bigger than 3. All right, solve for x, put it in order, smallest to largest with x in the middle. That means that x has to be greater than 3, but less than 7, right? So that is how we get it as a range. So think, any number in between 3 and 7, that would be 4, 5, or 6. Any of those 3 numbers could be that third side length of that triangle. And you could test that out too, right? Because 2 plus 5 is 7. All of these are less than that. Okay, and if we took any of those with the smaller one, 2 plus 4 is bigger than 5. 2 plus 5 is bigger than 5. 2 plus 6 is bigger than 5. Okay, so what are the possible third side lengths for a triangle with the 2 given sides? So again, you create 2 inequalities, one with x going first. So x has to be less than 6 plus 12. And the other one with the larger number, obviously the larger number between 6 and 12 is 12. 12 has to be less than 6 plus x. Well, 6 plus 12 gives you 18, so that means x has to be less than 18. And if you subtract 6, that means x has to be greater than 6. So we now know that x has to be bigger than 6, but less than 18. There's your range of numbers. Notice this range is much bigger than the previous one. The previous one, our range was just 3 numbers, 4, 5, and 6. Now we have any numbers between 6 and 18 is 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. It's a much bigger range. Here, same thing. Start with x. X has to be less than 7 plus 13. And with the larger number, which is 13, 13 has to be less than 7 plus x. And this becomes x must be less than 20, and x must be bigger than, subtract 7 is 6. So that means x has to be bigger than 6, but x has to be less than 20. Okay, ordering angles and sides from largest to smallest. The smallest angle is opposite from the smallest side, and the largest angle will always be opposite from the largest side. So remember, opposite means away. Always draw an arrow away from what you're talking about. And obviously, the converse is true, right? The longest side is opposite from the largest angle, right? And the shortest side is opposite from the smallest angle. But if you're given the angle, you can also figure out what the side length is as well. So name the angles and sides from largest to smallest. Here in this example, we are given all of the side lengths. So that means we can figure out what the angles are. So what's the biggest side length? The biggest side length here is 50. So that means the angle opposite of 50 is C. So that means from largest to smallest, angle C is the biggest. All right, between 44 and 29, 44 is obviously bigger than 29. Opposite from 44 is angle A. Angle A is going to be the middle-sized angle. And 29 is the smallest side length, and opposite of 29 is angle B. So that means angle B is going to be the smallest. And you can do the exact same thing with the opposite with side lengths now. Okay, if I change the color, which angle is the biggest? We see that angle C is the biggest, and we point across. That means segment BA is the biggest. Between these, 60 is bigger than 50, so across from that is BC. Segment BC is the middle, and 50 is the smallest angle, so opposite from there is CA. Segment CA is going to be the smallest side length. And I think that's all I got. This one was much quicker, much shorter. Go Mustangs.